Students, we are back again with another video lesson. If you remember, in a previous lesson, we studied the standing wave in an air column. We have two different types of pipe, open pipe and closed pipe. When we say open pipe, it means that the pipe is open at both ends. So when we say closed pipe, it means that the pipe is opened at one end and it's closed at the other end. And if you remember, in a previous lessons, we studied the standing wave in open pipe at both ends. The standing wave will occur in a pipe open at both ends if the two ends are antinode. The simplest standing wave that exists in open pipe, the two ends, the pipe vibrates with two antinode and one node. The second harmonic in the pipe open at both ends consists of three antinode and two nodes. So we can say in an open pipe, the number of antinode is always more than the number of node by factor of 1. For example, if we have 3 nodes, we have 4 antinode for open pipe at both ends. In a pipe open at both ends, the number of nodes determine the number of harmonics. Number of nodes is equal to number of harmonic. If we have 3 nodes, it means that this is the third harmonic. In open pipe at both ends, like a string that we studied, all harmonics are present in open pipe at both ends. But in closed pipe at one end, if you remember, the simplest standing wave that exists or occurs in a pipe that closes at one end, the pipe vibrates with one antinode and one node. In a pipe closed at one end, or in a closed pipe at one end, number of antinode is equal to number of node. Okay, so we studied all harmonics and we proved all the equations to find the wavelength of each harmonic and frequency of each harmonic. But guys, be careful. The difference between closed pipe and open pipe is in the closed pipe only the odd harmonics are present. But in open pipe, like string, all harmonics are present, even harmonic and odd harmonics. But in closed pipe, only the odd harmonics like first harmonic, third harmonic, fifth harmonic, seventh harmonic. We don't have second harmonic and fourth harmonic. We don't have even harmonics in a standing wave closed at one end in a pipe. So we have some notes about the closed pipe. In a pipe closed at one end, number of antinode is equal to number of node. In which of the following number of antinode is equal to number of node? In a pipe closed at one end. In what? In a pipe closed at one end. The simplest standing wave consists one antinode. This is the simplest standing wave that occurs in a pipe open at one end. Guys, the open end is always antinode, the closed end is node. So the harmonics in this figure is equal to first harmonic, n is equal to 1. How can we know this is the first harmonic? Because this pipe vibrates with one antinode and two antinode. And how can you get this one for the number of harmonic? Number of harmonic in a pipe closed at one end is equal to number of antinode plus number of node minus 1. How many antinodes do we have? 1. How many nodes do we have? 1. 1 plus 1, 2. Minus 1 is going to be 1. Okay? For the second harmonic, guys, look. For the second harmonic, for the second harmonic, we have 2 antinodes and 2 nodes. This is closed pipe at one end. Look, how many antinodes do we have? 2. 1, 2. How many nodes do we have? 2. So this pipe is vibrating with which harmonic? This is the third harmonic. N is equal to 3. How do you know this is N3, this is third harmonic? Because To find number of harmonics in a closed pipe, A plus n minus 1 always. Okay? Number of antinode, 2. Number of node, 2. 2 plus 2, 4. Minus 1, 3. So this is the third harmonic. For the fifth harmonic, you have to do the same process. Okay? But we don't have N2 and N4 and the even harmonics. In a pipe closed at one end, both number of nodes and antinode determine the number of nodes, as I explained it for you. Okay? In a pipe closed at one end, only odd harmonics are present. Which type of harmonics do we have? Odd harmonics. What do you mean by odd harmonics? N is equal to 1, 3, 5, 7, 9. Okay? In a pipe closed at one end, the length of the pipe is equal to 1/4 of the wavelength when the pipe vibrates with the fundamental frequency. What do you mean by fundamental frequency? The simplest wave that occurs in a standing wave. The simplest wave in a pipe closed at one end. Okay? So this is the length of the pipe. What is this? L. Guys, how many wavelengths do we have here? We have only 1/4. 1/4 is equal to 1/4 wavelength is equal to what? The distance of the pipe. So what about wavelength? Wavelength is equal to what? 4L. Okay? So based on the fundamental frequency, we prove it lambda n in the pipe closed at one end is equal to what? Is equal to lambda is equal to 4L over n. So where did this 4L came from? This 4L came from the fundamental frequency. The fundamental frequency is, wavelength is equal to 4 times L. This is the longest wavelength. What is this? Longest wavelength. And frequency is equal to what, guys? Frequency is equal to NV over 4L, sorry. NV for the first harmonic, V over 4L. What is this? This is the lowest frequency. Okay? How can we determine frequency of the fundamental frequency for the standing wave closed at one end? V over 4L. L is equal to the quarter of wavelength, and wavelength is equal to 4L when the pipe vibrates with the fundamental frequency. But fundamental, this is lambda 1 fundamental wavelength is equal to 4L, lambda 1 is equal to 2L. When does wavelength is equal to 4 times the distance of the pipe? For what? For closed pipe. This is fundamental wavelength. What is this? This is fundamental wavelength in a closed pipe. In what? Closed pipe. But this is fundamental wavelength in what? In a string and pipe open at both ends. Both ends. When does wavelength is equal to 2L? In open pipe at both ends or in a string? In both. In both. String, standing wave for the string, and standing wave for the pipe open at both ends. It is fundamental wavelength is equal to 2L. But fundamental wavelength for the closed pipe is equal to 4L. Which one is bigger? Fundamental wavelength in a closed pipe or in open pipe? Absolutely in a closed pipe. Closed pipe is bigger than the fundamental wavelength of open pipe. Because wavelength is inversely related with the frequency. When the wavelength of the fundamental frequency of the closed pipe is bigger than the wavelength of the open pipe for the wavelength, fundamental wavelength for the open pipe? It means that frequency of the closed pipe is less than frequency of the open pipe. Guys, I'm going to repeat, please. Listen carefully. Which one has more fundamental wavelength? When we say fundamental wavelength, it means that lambda 1. Which one has more lambda 1? Open pipe or closed pipe? Absolutely the closed pipe. Closed pipe has more fundamental wavelength than the open pipe by factor what? By factor 2. The fundamental wavelength of the closed pipe is bigger than the fundamental wavelength of the open pipe by factor of 2, or twice as much of the fundamental wavelength of the open pipe. But for the frequency, because frequency is inversely related with the wavelength at constant speed, which one has more fundamental frequency? Open pipe or closed pipe? Absolutely, the open pipe has more frequency. Its frequency is bigger than by factor of 2. Or you can say the frequency of open pipe is bigger than the frequency of closed pipe by factor of 2. It's twice as much of the frequency of the closed pipe. Okay? So this is very important, guys. Be careful. The movement of air molecules is restricted at the closed end, obscures in the closed end, and making this a node. Okay? So that is why the closed end is a node, which means the molecules are not free of motion. In this case, one end of the pipe is node and the other end is antinode. In air column, the produced frequency is inversely proportional to the length of air column. As the length of the air column makes it shorter, the frequency of the sound increases. Inversely proportional to the air. Okay? The fundamental frequency F1, fundamental frequency. What do you mean by fundamental frequency F1? In a pipe open at both ends, twice as much the fundamental frequency F1 of a pipe closed at one end. Guys, can we say F1 in open pipe is equal to twice frequency of what? Of closed pipe. F1 of closed pipe. Okay? So, and also you can write down like this: the fundamental frequency for the closed pipe is equal to half of the fundamental frequency of the open pipe. For the wavelength is the same thing, but inversely. Okay? How? The fundamental wavelength of closed pipe is equal to twice as much the fundamental wavelength of the open pipe. And you can write down like this: the fundamental lambda 1, it means that fundamental wavelength, fundamental of open pipe is equal to half of wavelength, the fundamental wavelength for closed pipe. So this relation is very, very important, guys. Be careful. Maybe they will bring in the exam. Which of the following is correct? F1 open pipe is twice as much F1 closed pipe? Yes. F1 closed pipe is equal to half of F1 open pipe? Yes. Lambda 1 closed at one end, closed pipe, is equal to twice lambda 1 open pipe? Yes. Lambda 1 open pipe is equal to half of the lambda 1 of the closed pipe? Yes. All are correct. Be careful. Okay? They have the same because the wavelength closed at one end. Twice F1 of the open pipe is twice of F1 of the closed pipe. At one, if they have the same length at constant L. Okay? And the wavelength of the open pipe is half of the wavelength in closed pipe. Okay? Examples of musical instruments that are closed at one end: clarinet or trumpet. But they do not bring in the Wizari exam which of the following instrument is closed pipe or open pipe. Okay? But this is just for information. As the temperature of the medium increases, guys, when the temperature increases, according to this relation, 2L for open pipe, 4L for the closed pipe. It doesn't matter, okay? Guys, when does the speed of the sound gets higher? When the temperature gets higher. When the temperature gets higher, what happens to the speed of the wave? Becomes more. When the speed becomes more, what happens to the frequency? Becomes increases at constant L. Okay? Why does pipe closed at one end have a different harmonic series than the open pipe? Because pipe closed at one end is different from the pipe open at both ends. Because the closed end is a node, while an open end is antinode. Okay? Why all harmonics are present in open pipe at both ends? Because both ends are antinode. And because the number of antinode is bigger than number of node by factor of 1. So, but why only the odd harmonics are present in closed pipe at one end? Because number of antinode is equal to number of node, and we have the simplest standing wave, we have one antinode and one node. To determine the number of harmonics, we have to add up the number of nodes and the number of antinodes minus 1. Okay? Question 26, guys. Look at this question. Very good question. A student records the first 10 harmonics for a pipe. Okay? Like, for example, 10 hertz, 20 hertz, 30 hertz, 40 hertz, 50 hertz. Okay? The second frequency is like, this is F1. Okay? Fundamental frequency, F2, F3, F4, F5 until 10. Okay? 20 hertz, 30 hertz, 40 hertz, 50 hertz, 60 hertz. Okay? Assume that we have 10 harmonics. Okay? This is F1, F3. Okay? And it doesn't necessary to write down this. Okay, now I'm going to tell you why. Okay? If student records 10 harmonics for a pipe, is it possible to determine whether the pipe is open or closed? So this is very important. Can you determine just by the records, okay, by the harmonics, which pipe is closed and which pipe is open? By comparing the difference in frequencies between the adjacent harmonic with the fundamental frequency, can you determine whether the pipe is open or closed? Yes, of course you can do it. Between the closed pipe and open pipe, this is for open. Assume that this is for closed. So, what is the difference between fundamental frequency in the string and the fundamental frequency in the open pipe? There is no difference. Both, they have the same fundamental frequency, guys. So we cannot determine whether this is open pipe or this is string. Why? Because in a string, standing wave in a string, harmonic is in a string, like guitar, banjo, and the harmonic is with the open pipe, they have the same fundamental frequency. If you remember, fundamental frequency for string, for what? For string, is equal to what? V over 2L. What about F1 for open pipe? Is equal to still V over 2L, yes. Guys, which one has more fundamental frequency? F1 in open pipe or F1 in string? Both, they have the same fundamental frequency. Both, they have the same wavelength. We cannot determine whether this instrument is strings or this is open pipe because they have the same fundamental frequency. But for open and closed pipe, can we say they have the same fundamental frequency? No. Which one has more frequency? The frequency of the fundamental for open pipe has more than the frequency of the closed pipe. Guys, this is fundamental frequency. F1 is equal to what? Is equal to 10 hertz. F3 minus F2, 30 minus 20, 10. 40 minus 30, 10. 50 minus 40, 10. So can we say that F3 minus F2 is equal to F1? Yes. F4 minus F3 still is equal to F1? Yes. What we have in the fourth harmonic? 40 minus 30, 20, which is equal to F1. F5 minus F4, F1. So can we say that for the open pipe, delta F is equal to F1? Yes. Is it clear? 50 minus 40 is still equal to 10 hertz. So can we say delta F is equal to F1 in open pipe? Yes. For the open pipe, how can you know this pipe is open if delta F is equal to F1? What about for the closed pipe? For the closed pipe, if delta F is equal to 2F1, how? Delta F is equal to what? F3 minus F1 is equal to 2F1. Let's check. F3 is equal to what? 30. 30 minus 10, 20. 2 times 10, 20. Okay? F3, 30 minus F1, 10 is equal to 2F1. F1 is 10. Yes. 30 minus 10, 20. 2 times 10, 20 hertz. Another tone or another harmonics. Guys, delta F is equal to 2F1. For what? For closed pipe. Delta F between F5 and F3 is equal to F5 minus F3 is equal to 2 times F1? Yes. How? F5 is equal to what? 50 hertz. Minus F3, 30 hertz. Is equal to 2 times F1, 2 times 10 hertz. 50 hertz minus 30 hertz is equal to 20 hertz. 2 times 10, 20 hertz. When does delta F is equal to 2F1? When the pipe is closed. When does delta F is equal to F1? When the pipe is open at both ends. When difference in frequency delta F is equal to F1, so we can determine whether the pipe is closed or open. Yes, the answer is yes. This difference will equal the fundamental frequency if the pipe is open at both ends, and this, like delta F is equal to F1, but will equal twice the fundamental frequency in the pipe closed at one end when delta F is equal to F1. You cannot determine, guys, you cannot determine whether the pipe is open at both ends or this is a string because they have the same difference in frequency. So look at this note. It's very, very important, guys. Listen carefully. Pay close attention for this note. What do you mean by F1 is the lowest frequency? If the question asks to you to find the highest, the lowest frequency, what do you mean by lowest frequency? F1. What is F1? Lowest frequency. Which is called fundamental frequency. Occurs when n is equal to 1. Okay? For what? For string, for pipe at one end. Okay? And for the string also, when the n is equal to 1, it means that we have 2 nodes and 1 antinode. This is for string. But for the open pipe, n1, it means that we have 1 node and 2 antinodes. Lambda 1, what is lambda 1? Longest wavelength. If the question asks us to find the longest wavelength, what do you mean by longest wavelength, guys? It means that wavelength 1 for the fundamental wavelength. Fundamental wavelength is what? Longest wavelength, okay? You have to use F1 and lambda 1. Look at this question, guys. The third harmonic of guitar string, third harmonic, F3, for guitar string is equal to what? 345 hertz. What is this? This is the third harmonics for the string. If the speed of the wave on the string is 345, speed 345 meter per second, what is the longest possible standing wavelength? What is unknown? Longest wavelength. What do you mean by longest wavelength? Lambda 1. fundamental wavelength. And what is the lowest frequency? Okay, what is the longest wavelength? What do you mean by longest wavelength? Lambda 1. Guys, lambda 1 is equal to what? Lambda 1 is equal to V1 over F1. And don't write V1 because V is constant. V is what? V is constant. Lambda 1 is equal to what? V over F1. Do we have V? Yes. Do we have F1? No. But instead of F1, what we have? We have F3. How can you determine F3 by F1 by giving F3? If you remember, there is a relation between F3 and F1. F3 is equal to 3 times F1. F3 is equal to what? Frequency of harmonics is equal to what? The integer numbers of multiplied by the fundamental frequency. What is the frequency of harmonics? An integral multiple of the fundamental frequency. F3 is equal to 3F1. What about F1? Is equal to what? F3 over 3. F3, 345 divided by 3 is equal to 115 hertz. Guys, what is this 115? This is F1. F1 is equal to what? 115 hertz. Can we say this is the lowest frequency? Yes. Okay. Lambda 1 is equal to what? 345 V divided by F1. Do we have F1? No, we didn't have, but we found. We found F1, 115, which is equal to what? 3 meter. Okay, what is the wavelength? It is equal to 3 meter. Longest wavelength means that lambda 1. So the frequency should be F1, lowest frequency. So this is summarizing of the string, open pipe, closed pipe. This is fundamental frequency for the string consists 2 knot, 1 anti-knot. Fundamental frequency for open at both ends, 2 anti-knot, 1 knot. Fundamental frequency for the closed pipe, 1 anti-knot, 1 knot. Okay? I wrote all things and the differences between all of them. A flute is similar to a pipe open at both ends. What is flute? A pipe open at both ends. Guys, look. The pipe is open at both ends. This is very important. Before solving the question, you have to determine this pipe is open or closed. It should be mentioned in the question. While clarinet is similar to pipe closed at one end. How many instruments do we have? 2. Flute is open pipe. Clarinet is closed pipe. Explain why the fundamental frequency of the flute is about twice that of the clarinet. Why frequency F1 of flute is equal to twice F1 of clarinet. Okay? Of what? Of a clarinet. Now I'm going to prove for you. Divide both of them. F1 for flute divided F1 for clarinet. F1 for open pipe. Flute is open, clarinet is closed. Flute is what? Open pipe. But clarinet is what? Closed pipe. F1 for the flute for open pipe, F1 is not equal to V over 2L? Yes. What about F1 for clarinet, closed pipe? V over what? 4L. V with V cancel. L with L cancel. What is remain, guys? F flute divided F clarinet. 1 over 2 divided by 1 over 4. 1 over 2 times 4 over 1. Cancel. Becomes what? 2 over 1. Okay? So, frequency of the flute, which is open at both ends, over frequency of the clarinet, which is closed at one end, is equal to 2 over 1. Yes. Cross product. 1 times fluid, F fluid, F of fluid. 2 times frequency of the clarinet, 2 frequency of clarinet. Now I prove it for you. The frequency, fundamental frequency for the fluid is equal to twice as much the frequency, fundamental frequency of the closed pipe. Okay? The first possible wavelength 2L for the fluid and 4L for the clarinet, because the speed of the sound is the same and the fluid's fundamental frequency is twice of the clarinet. So this is very important, guys. Can we say fundamental frequency of the clarinet is equal to half of it is fundamental frequency of the fluid? Yes, both are correct. Question 25 in chapter review. The fundamental frequency of any note produced by fluid will vary slightly with the temperature change. Temperature change in the air. For any given note, will an increase in the temperature by increasing temperature produce a slightly the higher fundamental frequency or slightly lower one? For the fundamental frequency for any device like string or pipe is equal to what? F1 V over 2L or 4L. By increasing temperature, guys, when temperature gets more, what happens to the speed? Gets more. What about fundamental frequency? Is still increasing. V increase, F increase at constant L. As the temperature increases, the speed of the sound in the air increases, because F1 is directly proportional to the V. Likewise increase, okay? If two pipes with the same length, with what? Same length, L1 is equal to L2. One of them is open at both ends and the other closed at one end. We have two pipes, closed pipe and open pipe, but they have the same L. This is closed pipe and this is open pipe. We have two pipes with the same length. With what? They have the same length, okay? But one of them is closed and the other is open at both ends. If the fundamental frequency of the pipe that open at both ends is 100 hertz, if the fundamental frequency of pipe that open at both ends, F open, F1 open is equal to what? 100 hertz. What is the fundamental frequency of the pipe closed at one end? What is F1 closed? As I proved it here for you, F open is equal to twice of F closed. F open is equal to twice of F closed. What about F closed? F1 closed. F1 closed equal to what? Is equal to F1 open divided by 2. Do we have F1 open? Yes. 100 hertz. Divided by 2, it's gonna be 50 hertz, and this is without a question, it is very important. The final result is what? 50 hertz. Look at the sample problem 4b. What are the first three harmonics in 2.45 meter long? What is this 2.45? This is L. That is open at both ends. What are the first three harmonics of this pipe when one end of the pipe is closed? Guys, what are the first three harmonics for L, pipe open at both ends? For open pipe, the first three harmonic is what? F1, F2, F3 unknown. But in the second case, what are the first three harmonics of this pipe, the same pipe when it's closed? Closed pipe. What is unknown? F1. F3, we don't have F2, guys. And F5 is equal to what? Speed is constant, 345 meter per second. For open pipe, guys, For what? At first, for open pipe. For open pipe, F1 is equal to what? V over 2L. V, 345. 2 times L, 2.45. By calculator, you will get 70.4 hertz. What is this? This is F1. What about F2? Don't write 2V over 2L, 2V over 2L, because we have F1, 2F1, F3, 3F1, F4, 4F1. 2 times 70, it's gonna be what? 141 hertz. F3, 3 times F1, 211. But guys, look at, for the closed pipe, the situation is completely different. Why? Because for the closed pipe, F1 is equal to what? V over 4L. V 345 divided by, for the same length, 2.45. F1 for closed end is equal to 35.2. Is equal to what? 35.2 hertz. What is this? F1. What about F3? Is equal to 3F1. 3 times this number. F5, 5 times this number. Practice 4B question 1. What is the fundamental frequency? What do you mean by fundamental frequency? F1. This is L and this is V. F1 is equal to V over 2L. A fluid is essentially open pipe. The length of the fluid is 66 centimeter. You have to convert to meter, 0.66 meter. What are the first 3 harmonics? F1, F2, F3. F1 is equal to V over 2L. V, 2L. F2, 2 times F1. F3, 3 times F1. String, this is length. Convert to meter. This is frequency, fundamental frequency. What is the speed? You have to rearrange. If we have F1, V over 2 times 0.1, V is equal to what? 440. Rearranging equation, you can find V. Question 29. What are the first 3 harmonics of a note produced on a 31 centimeter long violin? This is L. And this is V. Okay? What is unknown? The first 3 harmonic. F1, F2, F3. F1 is equal to V over 2L. F2 is equal to 2F1. F3 is equal to 3F1. It's too easy, guys. That's all for today. Inshallah, in the next lesson, we will solve the other questions, and also we're going to solve the standardized test strip, and we will study the sound quality. Thank you for listening, and keep up your best doing.